solve this math challenge. Here's the question. Solve for the value of x plus y given that x plus xy plus y equals 68. You can pause this video if you want to give this problem a try. And now let's answer this question together. So, the given is you have x plus xy plus y equals 68, wherein x and y are both positive integers, and our goal here is to solve for the value of x plus y. Now, we're given one equation, and our goal is to solve for the sum of x and y. So, how can we do that? One way to answer this question is to use this strategy, which is the Simon's favorite factoring trick, or SFTT. Now, how does it work? Simon's favorite factoring trick, it involves adding a constant term to both sides of the equation so that the factoring on one side can be accomplished. Now, we will use this method or this trick to answer this question. Now, the question is, what constant do we need to add so that one side of the equation is factorable? Now, if we add 1 on both sides and rearrange some terms a little bit on the left-hand side, then xy plus x plus y plus 1, this is factorable. If we factor this, we get x plus 1 multiplied by y plus 1. Now, if we multiply this to binomial, we get xy plus x plus y plus 1. So again, let's go back to its factor form. We will use this later. And on the right-hand side, 68 plus 1 will give us 69. And now, at this point, take note that x plus times y plus 1 equals 69. And we know that x and y are both positive integers. So what we're going to do here is to factor out 69. And 69 can be factored as 23 times 3 or 3 times 23. Now, why not we use 1 times 69? Now, take note. If we have 1 times 69, one of its factors is 1. So, one of the variables is either x or y becomes 0. And we don't want to have that 1 because we know for sure that x and y are positive integers. Also, no need to consider the negative factors of 69. For example, negative 23 times negative 3. The reason is the value of x and y becomes negative. And we don't want to have a negative value for x and y. So, in this question, we only have two cases. The first one is x plus 1 times y plus 1 equals 23 times 3. Or, on case number 2, we have x plus 1 times y plus 1 equals 3 times 23. Now, on case number 1, we can say that x plus 1 equals 23 and y plus 1 equals 3. On the second case, we can say that x plus 1 equals 3 and y plus 1 equals 23. Now, let's solve for the value of x and y. Let's have first the case number 1. If we add 1 on both sides, on the first equation, we get that the value of x must be equal to 22. Also, if we subtract 1 on both sides on the second equation, we get that the value of y must be equal to 2. On the other hand, on case number 2, if we subtract 1 on both sides on the first equation, we get that the value of x must be 2. And if we subtract 1 on both sides on the second equation, we get that the value of y must be equal to 22. And take note, we want to find the value of x plus y. Now notice, on both cases, x plus y must be equal to 22 plus 2, or simply 24. Therefore, our final answer, what is the value of x plus y? And our answer is just 24. Therefore, given that x plus xy plus y equals 68, then the value of x plus y must be 24. And as always, we are done.